Hello, welcome to this video. So this problem will be about conventional problem about a quadratic curve, about quadratics. So first of all, in part A, so part A, so we have a quadratic function, so fx, so maybe fx, so equals 36x minus x squared. So of course, you can first of all arrange the polynomial in descending powers of x. So using the method of computing the square, so find the vertex coordinates. So here, in order to rewrite the coefficient of x squared into 1, so we try to take negative 1 out, to become x squared minus 36x. And then now, this is very important. So the coefficient of x, inside the bracket, the coefficient of x is negative 36. Half it, so that will be negative 18, and then square it. So that's why here, so that will be x squared minus, so half it, negative 18, and then square it. So that's why here, will be plus 324. And then in order to strike the equality, so that's why we need to minus 324 back. So and then we only need the first 3 terms. So minus times minus will becomes positive. So here I refer to this minus times minus will becomes a plus sign. And then finally the first 3 terms by using the formula O1 or of course your mental math. So this would be a perfect square. And then we can then try to use the vertex form. Try to by using this computing square method or the process. So we try to rewrite the quadratic function in general form into its corresponding vertex form. And then of course from this vertex form we can directly write down the required vertex. So that will be 18, 324. And that's part A. And part B, so we are looking at B1. So the length of a string is 108 meter. 108 meter. And then it cuts the string into 2 pieces. One piece is used to enclose a rectangular restricted zone of a meter square. So a meter square. So this zone, a meter square. And then the other part, is used to divide the restricted zone into 2 rectangular regions as shown in figure 2. Well, that means 108 meter. This is the first part. So this is just the first part. And then this is the second part. So this is x. So that means this is also x, and this is also x. So that's why here we have 3x. So and then we have the length of the rectangle. The length of the rectangle seems that we do not know. But here, so we have one part and then 2 lengths. So that's why here we have 3x and then 2y, and then sum them up. That will be 108. And then we try to make y as the subject, so that's why y equals 108 minus 3x over 3. Let me correct, 1 over 2. So that's why here we have x and we have y, so that's why we can express a. So a would be x times y, and then y would be 108 minus 3x over 2. And then here, okay, I try to divide, so 108 divided by 2 will be 54, and then 3 divided by 2, so that will be 1.5. So that's why the answer, okay, will be negative 1.5 x squared plus 54x. And that's the answer for part B1. So finally part B2. So part A's answer, okay, would be 18, 324. And then B1, A would be negative 1.5 x squared plus 54x. So the guard claims that, oh, how come the guard, okay, anyway. So the area of this restricted zone can be greater than 500 meters squared. So that will be about the area. So of course, yeah, okay, so we want to find the optimum value of A. So that's why here, of course, okay, you can A equals negative 1.5 x squared plus 54x. And then from part A, okay, so this is the vertex, but the corresponding vertex form. The corresponding vertex form is negative the square of x minus 18 plus 324. So here, and then by looking at this part, with this, well, it seems that not really in common. But here, okay, if you try to pull out the 1.5 out, so actually everything becomes here. So plus 36x. Oh, you can see that it's exactly the same with part A. And then you can use, okay, the vertex form from part A also. No need to do the computing squares again, because actually for the computing square, it's quite tedious. Am I correct? So and then you can see the final form, so that will be negative 1.5 and x minus 18 all square, and then plus 486. Okay, so and then with this vertex form of A, so you can see that negative 1.5 is negative, so that's why here we can claim that the greatest A, okay, the greatest A would be 486, which is less than 500. Okay, so that's why it cannot be greater than 500 meters squared, because the greatest A already 486, and which is less than 500. So that's why you can see the claim is disagreed in this way. Okay, and then that will be done to this problem. Okay, so thank you for watching.